Hello and welcome to Science Monitor. Through this weekly program, we aim to acquaint you with some of the major developments in the field of science and technology and how these developments can change our life and environment. But let us begin by taking a look at the headlines. Adding to India's navigation satellites, the fourth in the series, IRNSS-1D launched successfully. 6 months into orbit, Mangalyaaan's findings continue to astonish researchers. Nobel laureate of Indian origin Sri Venkataraman Ramakrishnan elected to head the oldest scientific academy in the world, the Royal Society. Soil erosion during rainfall. Will American technology provide a solution in India? In today's In Focus, we will explore the concept, design and working of a solar aircraft, SI-2, one of the biggest and most relevant experiments of our times. And in science, you can use Shiva Kumar's award-winning high-accuracy OCRs to take study material to the visually challenged. And now news in details. Inching towards the country's own GPS and navigation system, ISRO has successfully launched IRNSS-1D, the fourth satellite in the 7 series navigation satellite system. The launch that was earlier scheduled for 9th of March was deferred after an anomaly was found in one of the telemetry transmitters of the spacecraft. Here is a report.
Adding another feather to its cap of success, scientists of ISRO have successfully launched India's fourth navigation satellite, IRNSS-1D, on 28th March. IRNSS-1D was launched on board PSLV C-27 at 17:19 hours yesterday evening from Satish Dhawan Space Centre, Sriharikota. The launch has put India's own navigation system on par with the global positioning system of the US. The launch followed after the initial launch plan on March 9th was deferred, following the discovery of a fault in one of the telemetry transmitters of the satellite. IRNSS-1D is the fourth out of 7 in the Indian Regional Navigation Satellite System, that is, IRNSS series of satellites after IRNSS-1A and 1B and 1C. The Indian Regional Navigation Satellite System, in short known as IRNSS, is India's indigenous satellite navigation system and has been developed by ISRO. The space and ground segment and user receivers of this system are all being built in India. Unlike the existing global navigation systems, the IRNSS navigation system will be under the total control of the Indian government. IRNSS aims to provide navigation and security services to India and to provide accurate position information services to users in the country as well as the region extending up to 1,500 kilometers from its boundary.
You can independently locate yourself. You can determine your position in terms of latitude, longitude and height. So this will give us an independent geographic positioning system in the country.
The system will help in terrestrial and marine navigation, disaster management, vehicle tracking and fleet management. While after the launch of IRNSS-1D, technically the navigation system will become functional, the remaining 3 satellites yet to be launched will make it more accurate and efficient.
Dodging several obstacles and gathering data continuously to help deepen our understanding of Mars, India's Mars Orbiter mission completed 6 months in space on 24th of March this year. The mission not only reached the red planet in its maiden attempt, but also is good enough to work beyond its estimated duration. The spectacular images captured by the orbiter and the interesting data gathered in these 6 months has surprised the scientific community. Take a look.
Mars Orbiter mission, popular as Mangalyaan, completed 6 months in the red planet's orbit successfully on 24th March 2015. During the course of these 6 months, Mangalyaan, the country's first interplanetary expedition, has created many historical milestones. Orbiting Mars for 6 long months, MOM's Mars Color Camera has so far captured over 300 plus spectacular pictures of the Mars surface. These include full disk image of Mars, mountains, dead volcanoes and dust storm activities on the planet. In one of the first high-resolution images of Mars captured by the orbiter, it captured the atmospheric movement in the northern hemisphere. The image is one of the first global images of Mars, with more details than were captured by the Hubble Space Telescope. The camera has also successfully captured the close-up of various impact craters on the surface of Mars. Valles Marineris, a system of canyons on Mars, and the Martian satellite Phobos. The special instruments on board Mangalyaan have been conducting various experiments to study the Martian surface. These experiments include analysis of the mineral composition of Martian soil and its atmosphere for methane gas. While the methane sensor for Mars has been measuring the natural gas in the Martian atmosphere and mapping its sources, the Lyman Alpha Photometer is studying the atmospheric process of Mars and measuring the deuterium and hydrogen ratio and neutral particles in its upper atmosphere. Mangalyaan's Mars Exospheric Neutral Composition Analyzer and Thermal Infrared Imaging Spectrometer has been gathering data and analyzing the composition of Mars and measuring the day and night temperatures to map the surface composition and mineralogy of Mars. After the results of tracking of MOM showed that the orbiter has sufficient fuel to last longer, the mission has been extended for another 6 months to further explore the red planet and its atmosphere. Glorified as one of the most successful scientific feats in the field of space science, India has hence become the first nation to reach Mars in its maiden attempt and the first Asian country to reach the red planet sphere.
Known as Venki among his peers, Sir Venkataraman Ramakrishnan is a researcher par excellence. The India-born Nobel laureate will now support excellence in science as the president of the prestigious Royal Society, the oldest scientific academy in the continuous existence in the world. Take a look at this report to know more about this interesting development.
In a proud moment for India, the Indian origin scientist and Nobel laureate Sir Venkataraman Ramakrishnan has been confirmed as the President-elect of Britain's prestigious Royal Society. Sir Venkataraman Ramakrishnan was chosen after a ballot of the fellowship at a meeting of the Society's Council. 63-year-old Sir Venkataraman Ramakrishnan, currently the Deputy Director of the MRC Laboratory for Molecular Biology and a Fellow of Trinity College, Cambridge, will be the first Indian origin scientist to hold the post. Sir Venkataraman Ramakrishnan, popular as Venki among his peers, will succeed Nobel laureate Sir Paul Nurse and will take up the post of President of the Royal Society on 1st December 2015. A world-renowned biophysicist, he was awarded the Nobel Prize for Chemistry in 2009, along with Tom Stites and Ada Yunath, for discovering the precise structure of cellular structures called ribosomes. His pioneering work is on how genetic information is translated by the cellular machineries called ribosomes to make proteins and the action of antibiotics on this process. For his outstanding contribution to biological science, Sir Venkataraman Ramakrishnan was knighted by Britain's Queen in 2012. The Royal Society, for which Sir Venkataraman Ramakrishnan has been elected as the President, dates back to 1660 and is the oldest scientific society in existence. The Society functions as a scientific advisor to the British government and as the UK's Academy of Sciences by funding research fellowships and scientific start-up companies. The Society works towards upholding the motto Nullius in Verba, meaning take nobody's word for it, and encourages establishment of facts via logical experiments. With this appointment, Sir Venkataraman Ramakrishnan will join the League of Luminaries like Christopher Wren, Isaac Newton, Humphrey Davy and Ernest Rutherford, who have served as presidents of the Royal Society in the past. The president of the society is a key advocate for science in the UK and the world.
Sharing scientific research and technology is one of the biggest achievements of globalization. Many a problem have been solved through technology sharing. In fact, countries sign many MOUs with other nations to share and exchange technical solutions. In just such a development, the Ukadam tank of Coimbatore is all set to test a novel American technology called Techrevetment to strengthen the bunds of lakes that suffer drastically during rains. So how does Techrevetment overcome the shortcomings of the conventional bunds? Let us explore more in this report.
Damaged bunds leading to water overflow and soil erosion are not uncommon in India, especially during the monsoons. In cities like Coimbatore and Tamil Nadu, with about 3 dozen lakes, robust lake bunds are a must. Keeping in view the safety of lake bunds and preventing massive soil erosion during rainfall, the civic agency in Coimbatore has implemented a novel technology called Techrevetment. Techrevetment is an American technology that has been adopted to strengthen the bunds of Ukadam Big Tank, one of the largest water bodies in the city. The corporation has sanctioned 45 lakh rupees for the first phase of implementation of the technique. The bund, constructed using 2 layers of geofabric material, is being constructed for a stretch of about 1.5 kilometers. The technology, widely used in America and Europe, will help building a monolithic structure with higher tensile strength and grip than the conventional bunds, and that too without draining of lake water.
This technology is by using the geofabric. Geofabric is the material used. It is a monolithic structure. Comparing with the other traditional bund strengthening materials like hollow block or other structures, it is a monolithic one, which means it would provide for more tensile strength and grip than the conventional styles and technology.
The technology is also eco-friendly and will last for over 75 years without affecting the fish culture of the lake. The work is expected to be completed within 2 months. Based on its success, the technology will be extended to other lakes.
And now it is time to take a short break. We'll be right back. Keep watching Science Monitor. Welcome back. After the break, you're watching Science Monitor. Let us now have a look at some important science and technology activities happening in India and around the country in our segment Science Express. President of America Barack Obama has praised the work of budding Indian-American teenage scientists who showcased their innovative exhibits at the White House Science Fair 2015. The novel exhibits created by the students included an algorithm to identify potential drugs for cancer, Ebola and tuberculosis. 35 student teams exhibited their projects in the fair, of which 12 were personally viewed by President Obama. Indian activist Rajendra Singh has been awarded the prestigious Stockholm Water Prize for 2015. Rajendra Singh, popular as the Waterman of India, is known for his innovative water restoration efforts and contributions towards improving the country's water security in villages. Working in the arid state of Rajasthan, Singh has worked towards building about 8,600 rainwater storage tanks and other structures to collect water, thus solving water crisis in about 1,000 villages across the state. Observing the World TB Day and participating in the Reach Lilly MDR TB Partnership Media Awards, Union Minister for Health and Family Welfare JP Nadda called for active participation of public and stakeholders in controlling tuberculosis in the country. The minister on this occasion also presented the awards for excellence in reporting on tuberculosis to 4 journalists. Dr. Anurag Bhargav from the Himalayan Institute of Medical Sciences delivered the special address TB Control in India, Beyond the Bug and Drugs on this occasion. In a proud moment for the country, Indian origin researcher Dr. Minoti Apte has been named as the New South Wales Woman of the Year 2015 for her contributions to medical research, tertiary education and the Indian community. Dr. Apte, a professor of medicine at the Southwestern Sydney Clinical School of University of New South Wales, works on pancreatic cancer to find out how and why the cancer is so aggressive and spreads so quickly. Solar Impulse 2, the solar-powered aircraft vouching for cleaner technologies, is being watched by every science enthusiast. The first of its kind, the Solar Impulse 2 is an engineering marvel in itself, quite different from the normal aircraft. Similarly, the challenges faced by this fully solar-powered aircraft during flight are also many. So how is this aircraft powered to face these challenges? How well is it equipped to achieve its aim? And what makes it different? Well, that is the focus of our special segment, In Focus.
After its stay at Ahmedabad and Varanasi, Solar Impulse 2 took off from India to continue its round-the-world trip. As the world tracks the flight of SI-2 through its Twitter account and by several other means, the challenges associated with the fully solar-powered aircraft are many.
We want to show that climate change is a fantastic opportunity to bring on the market new clean technologies that save energy, save natural resources of our planet, make profits, create jobs and sustain growth.
The zero-fuel aircraft, which is on a mission to prove that flying is possible without using fossil fuel, is designed rather differently. The wingspan of SI-2 is bigger than that of Boeing 747, that is about 72 meters, but it weighs around 2,300 kilograms, almost like a family car. The wings are fitted with over 17,000 solar cells which use only sunlight to power the engines. Also, these solar cells are as thin as a human hair and are protected by a thin UV-resistant and waterproof resin. The windows are made of multi-layered carbonate sheet which is better than glass in mechanical properties and safety. A special coating makes it anti-fogging too. Moreover, flying SI-2 is both a human and a technological challenge in itself. Piloting SI-2 can be a lonely affair as its 3.8 cubic meter cockpit has space only for one pilot besides oxygen supplies, food and survival equipment. Also for long trips, it would mean living up in the sky crunched in the cockpit for 5 to 6 days in a row with the multi-purpose seat functioning both as a reclining berth and a toilet. In the absence of any heating, the cockpit and the pilot can face extreme temperatures from plus 40 degrees Celsius to minus 40 degrees Celsius. For this purpose, there is a provision for high-density thermal insulation in the cockpit structure. Intelligent fibers have been used in the pilot's clothing to maintain a stable body temperature. Currently, the aircraft flies at the speed of a car, that is, between 36 to 140 km per hour, which means 16 hours flying from Muscat to India and 13 hours from Ahmedabad to Varanasi. Solar Impulse 2 has taken 12 years of feasibility study, which includes concept, design and construction involving 50 engineers and technicians 80 technological partners and more than 100 advisors and suppliers.
Childish excitement, I mean, really when you realize something that that is deep in your mind and deep in your body, but also responsibility, because it's 12 years of work, a lot of people and spend a lot of time, of their free time in this project. So, you know, there is a strong sense of responsibility to make sure that all the decisions which will be taken will be the right one.
Science Monitor team joins the audience to wish the pilots Burton Pickard and Andre Boschberg all the success as they take turns to complete the trip around the world in coming 5 months. Let us hope that the success of SI2 will provide the required thrust to research more on clean technologies and renewable forms of energy.
And what are the contributions of science to this week's history? Let us learn in our next segment, History of Science.
John Harrison, English clock designer and innovator, was born in Fulby, near Wakefield, in the West Riding of Yorkshire on 24th March 1693. Harrison is known for the invention of the marine chronometer, an instrument that can be used to determine the longitude of a ship at sea. The Indian Agricultural Research Institute, commonly known as IARI or Pusa Institute, was established on 1st April 1905. Situated in Delhi, it is financed and administered by the Indian Council of Agricultural Research. The IARI is India's premier national institute for agricultural research and education, and is the organization responsible for the research leading to the Green Revolution in India of the 1970s. Rakesh Sharma became the first Indian astronaut as he flew aboard Soyuz T-11 on 3rd April 1984. Rakesh Sharma, an Indian Air Force test pilot, flew to space as part of the Inter-Cosmos program. He spent 7 days, 21 hours and 40 minutes in space, conducting scientific and technical studies in biomedicine and remote sensing.
On to our next segment, Science You Can Use. As the world moves from printed text to e-content, here is an innovation that makes the translation easier and more efficient. Shiva Kumar, a young researcher from the Indian Institute of Science, has innovated a technology that can translate scanned documents into electronic text and also into Braille in a very short time.
Gone are the days of paperbacks and printed text. With products like Kindle readers flooding the market, e-texts are today the easiest source of information. Even while printed books are fast becoming obsolete, a lot of information and knowledge lies trapped in their pages. How can printed text be easily converted into e-text and more so into Braille for the visually challenged? The question has been addressed by a young researcher, Shiv Kumar HR, a PhD student at the Indian Institute of Science, Bangalore, and his guide, Professor A.G. Ramakrishnan. The team has developed a high-accuracy optical character recognizer, also known as OCR, for Kannada and Tamil languages.
OCR, what is called optical character recognition, which basically starts with the printed text on a book or a newspaper or any piece of paper, which is scanned and converted into an image, and then we have sophisticated algorithms which actually decode what is there in the image and finally come back with the text, and the text is saved as a Unicode string inside the computer or any other computable device.
This OCR can convert scanned pages of a printed document into e-text quickly and efficiently. This versatile tool also has a very user-friendly graphical interface called Print to Braille. The interface allows to quickly scan any printed book or document, and convert it into a Unicode text. A visually challenged person can then either listen to this Unicode e-text through any text-to-speech synthesis software.
We may even take a modern mobile phone, take a high-resolution picture of the page, and that can convert that into text, and that text can be fed into another software that we have called text-to-speech synthesis. So, this text in Unicode, if it is submitted, so that converts that text into actual speech in a human voice. Any text can be presented. Currently, we have supporting for Tamil and Kannada. Most of our work is for both Tamil and Kannada, but we are also interested in other languages. Some of our other works like OCR, we have also worked on Gujarati, Hindi, Telugu for example, but they are at different levels, whereas Kannada and Tamil, they are at a very high, directly usable or even productizable by an industry.
Or the e-text can be converted into Braille codes and printed using a Braille embosser. The use of this OCR reduces the time and cost required for the translation of the printed material into Braille. It also makes more books accessible to the visually challenged. The software has already been used to convert hundreds of Tamil books, including school and college textbooks, into Braille format. The Kannada version of the software has been shared with some voluntary organizations and individuals in Karnataka who are working with the visually challenged in the state. Recognizing the strong social relevance of the project, the Society for Research and Initiatives for Sustainable Technologies and Institutions has awarded Shiv Kumar with the Gandhian Young Technological Innovation Award for the year 2015.
Well, that is all for this episode of Science Monitor. Do tell us how do you like our program. You can send your feedback and suggestions. Our email ID is news@vigyanprasar.gov.in. You can also write into us at Vigyan Prasar C24, Qutub Institutional Area, New Delhi 110016. Well, that is all for today. We'll be back with fresh news stories on science and technology again next week. Till then, stay tuned and think scientific.